All right, welcome to Balancing. This is our reactions unit, pages 3 and 4 in the homework packets. Okay, so they're asking us to do two things on this assignment. A, classify the following equations as synthesis, decomposition, single replacement, double replacement, or combustion. Okay, and then it says to balance. And in order to get credit, you need to be showing some work. So the first thing we want to look at here, number 3, is which type of reaction is it? So I've got one capital letter reacting with two capital letters, and it looks like chlorine and iodine are replacing each other. They're switching spots. So it's definitely a replacement, and I have a single one before and a single one after. So I'm going to say single replacement. Now we learned 3 different ways to balance in class today. For some students it's very easy. For some students you just struggle with this a little bit more, and that's alright. So make sure if after this video you're still confused, look at the rainbow balancing video. That's also saved to the Unit 5 2018 playlist. Okay. So the ping-pong method that we worked with in class today, and I'm going to use a pencil, will be to cut my reaction in half. So I'm either dealing with the reactant half here or the product half, and then list our ingredients essentially. So I've got chlorine in this reaction, potassium, and iodine, and then I'm going to copy those 3 ingredients in the same order on the product side. So chlorine, potassium, and iodine. And then I just kind of want to take stock of how many I have to start with. So chlorine is one of my diatomic 7. I'm starting with 2, Cl2. I've got 1 potassium and 1 iodine to start with on the reactant side. On the product side, I've got 1 chlorine, 1 potassium, and 2 iodine. Okay. And then we're just going to work our way down. So, are my chlorines balanced? The answer is no. So I need to go to the smaller side, which in this case is the products, and I need to multiply it so that it matches the larger side. So, in order to turn my 1 into a 2, I'm going to multiply it by 2. So that's what I want to do. I'm going to go into the problem and actually do that. So if I put a 2 here, that gives me 2 chlorines, and now my chlorines are balanced. However, that also affects potassium. Okay? They're like your best friend and her boyfriend. You can't get more time with her without getting more time with him. They're a package deal, people. So that also gave me the unintended consequence of doubling my potassiums. Okay. So chlorines are balanced. Potassiums are not. So I want to go to the smaller side, which this time is my reactants half. And I need to multiply this so that it equals 2. And that means I'm going to multiply it by 2. So in order to do that, I put it as a coefficient here. And that doubles my potassium, but just like your other friend and his obnoxious girlfriend, they come together. Alright? So that also doubled my iodine, which is actually kind of great because I wanted 2 iodine on each side. So that gives me equal number of chlorine on each side, equal potassium on each side, equal iodine on each side. So we're done, which means my blanks are 1. Okay, so I've got 1 Cl2 plus 2 potassium iodides yields 2 potassium chlorides plus 1 iodine. Okay. Looking down at number 4, that one looks a whole lot more complicated. It doesn't have to be. But I see 2 compounds switching anions, so this one is a double replacement reaction. Okay, and I'm going to try and use some different colors to help with this. The first thing we want to do is make our lives easier by not opening up our polyatomic ions. Okay, so I've got hydroxide in parentheses on my reactant side and my product side. I've got SO4 sulfate on the reactant side and the product side. So I will not open those, because otherwise it is a huge pain in the butt to balance oxygen in different spots. We're not gonna. So when I take stock of what I have, my ingredients, I'm going to say calcium hydroxide as an ingredient. I'm keeping the OHs inside the parentheses. Aluminum and sulfate. Okay? I'm going to keep those together and make my life literally 10 times easier. You have no idea. I'm going to write down the ingredients in the same order on the other side. Calcium, hydroxide, aluminum, and sulfate. Okay, and then we'll figure out how many we have to start with. I've got 1 calcium here. I've got OH2, so 2 hydroxides, 2 aluminums, and SO4 3. So 3 sulfates, all on my reactant side. On the product half, I've got 1 calcium. I've got SO4 nothing, which means SO4 1, so 1 sulfate. I've got 1 aluminum and OH3, so 3 hydroxides, which means nothing is balanced. Actually, false statement. Calcium is balanced. Okay, I've got 1 calcium each side. Starting from the top, working my way down, calcium's balanced. Hooray. Move down. Hydroxide is not balanced. So what I wish I could do would be to turn a 2 into a 3 by multiplying it by a whole number. But the only way to make 2 into a 3 would be if I said 2 times 1.5. I don't want to do that. So when I have a 2 and a 3, it's called the least common factor, blah, blah, blah. We're going to multiply them together. So I'm going to make this one times 3 equals 6, okay? And this side times 2 equals 6, okay? I'm going to use my coefficient and put it in front of OH, because that's how I multiply the 2 I have times 3. Now I have 6 of them. And then over here, in order to get the OH times 2, I need to put it in front as the coefficient. That has unintended consequences, because we've got significant others that come together. So by multiplying my hydroxide by 3, I also multiplied my calcium by 3. And on this side, by multiplying hydroxide by 2, I doubled my aluminum. Okay? Which is really too bad, so sad, because my calciums were balanced. Now they're not. That's going to happen. That's why it's called ping pong. Ping pong, ping pong. It's okay. Calm down. Now I just have to rebalance my calcium. So I'm going to start back over at the top. I have 3 calcium on this side and 1 calcium on that side. So times blank equals 3. I would have to put a 3 there. Okay, so in order to actually do that in my problem, I use it as a coefficient. So calcium times 3. That also multiplies my sulfate times 3. Okay, so we can take stock. I've got 3 calciums on each side, 6 hydroxides on each side. I've got 2 aluminums on each side. And would you look at that? 3 sulfates on each side. So I'm balanced, which means this blank is just 1. I have 1 of them. So the ratio of coefficients, if we want to do it that way, I have 3 to 1 to 3 to 2. Okay, so 3, 1, 3, 2. And we're balanced. Okay, on the back, let's look at one more together with this ping-pong method, and then if you're not liking it, you can look at the rainbow balancing video. But we are going to cut our equation in half. Nitrogen, hydrogen, iodine. Nitrogen, hydrogen, iodine. And we want to keep them in the same order, that way we can compare across rows. This looks like another single replacement reaction, because I have a compound and a single, and iodine's replacing hydrogen here. It's a single replacement. Okay. I've got 1 nitrogen to start with, 3 hydrogens, and 2 iodines. Then I have 2 nitrogens, 2 hydrogens, and 6 iodine. Okay. So what I wish I could do would be to double my nitrogen. I'm going to go ahead and do that. Times blank equals 2, so that they're equal. I would say I have to multiply it by 2. So I put that number here. That also doubles my hydrogen, though. So in order to get twice as much nitrogen, I have to get twice as much hydrogen. They're a package deal. Okay. So my top nitrogens are balanced. My hydrogens are not, though. Okay. So right now I have 6 hydrogen on the reactant side. So it's a hydrogen times blank equals 6. 2 times 3 equals 6. So I'm going to put that 3 in front of the H right here. Okay, 2 times 3. And that doesn't change anything else, so we're all right. And then I look at my iodines. I've got 2 on the left and 6 on the right. So I need to change the smaller side, which is the reactant side this time. 2 times blank equals 6. That would be 3. So I'm going to put the 3 in front of the iodine. And that doesn't change anything else. So 2 nitrogen, 6 hydrogen, 6 iodine. We're done. Which means that one's just times 1. Alright, down here, a student, this is good review because our Unit 5 exam is kind of the 9 weeks exam. It's got Unit 3, 4, and 5 on it. Number 9, a student tests a material's malleability, melting point, and color. All of these properties are example of physical extensive properties, physical intensive properties, chemical properties, or not enough information. Yeah, I'm going to go ahead and just guess it's not that, because that would be a silly question then. In class we did this with chocolate, remember? So we have a little bit of chocolate and a big piece of chocolate. Would they have it in common, intensive, or would it be different, an extensive exception? So are they going to have the same texture, softness, bendability? Yeah. They're both going to melt in my hand. They're both brown, right? Color doesn't change just because the chocolate got bigger. So I would say those are in common properties and call that physical intensive. Number 10, look at the list below. Circle all of the chemical changes and underline all of the physical changes. So, for physical changes, we learned in Unit 3, physical changes can be undone. So if I physically change gold, it's still gold. If I chemically change it, it's not gold anymore. So if I melt gold, it's still gold. If I combust, which means to burn or blow up in the presence of oxygen, you can't unblow up. That would be chemical. If I evaporate something, like water, it would still be H2O. It's a state change. Corroding means to react with acid. That's got unreversible consequences. Rusting, changing color. That's chemical. To bend gold, it's still gold. To cut it, still gold. To burn it, okay, you can't unburn something. Sublimating, page 1 in our Unit 3 notes. That's a state change. Like solid carbon dioxide, dry ice, turning into gas carbon dioxide. And then react is always chemical. So if this felt rusty for you, go back and look at your Unit 3 notes, because both of these types of problems will be on your next exam and on the final, the one after. Okay, last thing, skeleton equation. I wanted to point out this word, number 13. Okay, skeleton equation means it's not balanced. And I know it's not balanced, and that's okay. So I've got 1 chlorine here, 2 chlorines there. It's not balanced, that's fine. So all they're asking is, what are the reactants? That's my front half. The beginning of the reaction are the reactants. The end product are the products. So I would say calcium and hydrochloric acid, HCl. Products would be calcium chloride, CaCl2, and hydrogen gas, H2. Okay, the end product. And what type of reaction is that? That looks like a single replacement reaction. Okay, make sure you are taking a look at your project that's due real quick if you're choosing to do one. Thanks, y'all.